Hi, you guys. We're getting close to the end. This is actually the homework 50 was the second to the last of the things. We only got one more coming. So this video is to do a few problems from homework 50 and then show you how we use the rational root theorem at the very end. So I'm going to do a few problems from homework 50, which is right up there. Homework 50, page 384, oral exercises 5, 7, 9, 11. Page 381, self-test 2, 1 to 7, all except 6A, and page 397 to 398, chapter review, 5 through 11, all except 7. And we're gonna do those. I am sending along with this I know I'm only doing a few problems from this. I am sending the answer key though. This answer key has everything worked out in great detail. So there you go. You could look at the answer key if I don't work out the one that you're wanting to see. Okay, so anyways, over here. First one, we're doing from page 384, oral exercises number 11. Remember, the directions on this were to just use the rational root theorem to find the possible rational roots. That's all there was to this problem. So here's how the rational root theorem works. If there are rational roots to this equation, they have to be of the form factors of the constant on top, so factors of 4, like plus or minus 1, plus or minus 2, plus or minus 4, those are the factors of 4 on top, over factors of 3 on bottom, plus or minus 1, plus or minus 3. Though every possible fraction we can make out of those tops and those bottoms is going to give us the possible rational solutions for this. So here we go. They are going to be, I do it in this order. All of these guys over 1, so plus or minus 1, plus or minus 2, plus or minus 4. It's each of these guys over 1. Then plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. So if there are rational solutions to this equation, they will be on this list. Okay? So that's how it works. If you wanted to go further and actually solve it, you would start trying these one by one to see if any of them work. And the way you test that is by seeing if they give you 0 as a remainder when you do synthetic division on them. Okay, I'm not asking you to do that on that problem, but if you did do it, more power to you. I don't even actually know if there's, I think there is one of these that works, but I don't remember off the top of my head. So anyways, that's it. Okay, this one is a little more involved. This is page 381, self-test 2, number 6B. 6A asked you to use Descartes' rule of signs, which we did not cover, so that's why I eliminated 6A from the homework. You didn't have to do 6A, okay? But 6B is important, so here we go. 6B, if 2 plus I is a root, the conjugate root theorem gives us that 2 minus I would also be a root. So I'm going to do the sum and the product. The sum of these is 2 plus 2 is 4. The product turns out to be 5. If you FOIL that out, you'll find out it's 5. So this is going to be the polynomial that contains these two roots. X squared minus the sum times x, so minus 4x plus 5. That polynomial contains those two roots. But again, that polynomial also contains those two roots. So this guy should divide evenly into this guy. So that's what I'm going to do now. Right next to the third. I'm making sure nothing is missing. Look, 4, 3, 2, 1, constant, right? There is no missing powers. If there is, I would need to put zeros in for them. Okay, so here's my division. Now, just long division. What am I expecting my my remainder to be? It better be 0. If it's not 0, there's a problem. Okay, so let's see. What does it take to turn x squared into 2x to the 4th? Well, it's going to take a 2 and an x squared, 2x squared. So I go right above this x squared term and put my 2x squared. Like that. Okay, this times this is 2x to the 4th. This times this is minus 8x to the 3rd. This times this is plus 10x squared. I want to subtract, but remember, I don't like to subtract. I like to add the opposite, making that minus, plus, minus. This is nothing. This is negative x to the third. This is plus 3x squared. Bring down the next thing. Bring down the minus x. Okay, what does it take to turn x squared into negative x to the third? It's going to take a negative and an x. Negative x. I put it right above this x. Okay, that gives me negative x to the third. This time this is plus x to the 4x squared, right? Because it's negative times negative is positive. Negative x times 5 is minus 5x. I want to subtract, or I'm going to be tricky actually and make it add the opposite. Make that plus, minus, plus, nothing, negative x squared, and plus 4x. Bring down the minus 5. And now what does it take to turn x squared into negative x squared? It's going to take negative 1. This times this is negative x squared. This times this is plus 4x. This times this is minus 5. And oh my gosh, I can't believe the good fortune that is with me. Plus, plus, minus, plus. 0 remainder. Oh my gosh. Oh my gosh. Wow, fortune is with me. Maybe I should go to the casino. No, don't. That's horrible, horrible thinking, because first of all, fortune is not with you. It would be a miracle if that did not get 0, because they told you that that thing is actually a root to that. If you didn't get 0, it would be a miracle. So do not go to the casino. Luck is not with you. Okay, so here we go. The other two guys are sitting inside of that guy. How do I figure them out? Set him equal to 0. 2x squared minus x minus 1 equals 0. Now, does this thing factor? If it factors, oh my gosh, great. If not, I would try quadratic formula. But I'm going to give it a shot and see if I can factor it first. Okay, 2x squared is going to have to be 2x and x. 1 has to be 1 and 1. It's either going to work this way, factoring, or it's not going to factor. Let's find out. I need the o's to subtract to be negative 1x or whatever. So 2x and 1x, yes, they do subtract to be x. Bigger one negative, so we need the 2x to be negative, so a minus there. We need the 1x to be positive, so there we go. So x is opposite this over this, negative 1/2 and positive 1. Those are my other two roots. So the entire solution set will be these two guys, negative 1/2 and 1, and these two guys, 2 plus or minus I. That is the 4 solutions. And actually, this is a good example. When we're talking about the rational root theorem, okay? Look, this is a good example. It's a 4th degree equation, but there are 2 rational roots, negative 1/2 and 1. Notice, negative 1/2 and 1 are of the form of factors of 5 over factors of 2. Yep, they would both be on that list. But then 2 plus or minus I would not be on the list because those are complex, right? But it says if there are rational solutions, they'd have to be factors of 5 on top over factors of 2 on bottom. And sure enough, these guys do fall into that category. So there you go. How about that? Okay, this one. You got these 2 roots. We want to invent an equation that has these guys as roots, has these guys for answers. So if 1 plus 3i is a root, the conjugate root theorem tells me 1 minus 3i would also have to be a root. So let's see. The sum is 1 plus 1 is 2. The 3i and negative 3i cancel. The sum is 2. The product is a little bit more involved. In fact, I'm going to bring it over here. I'm going to need a little more room to work it out. So here we go. The product is going to be 1 plus 3i times 1 minus 3i. Okay, I'm going to FOIL that out. So here we go. 1 times 1 is 1. Then I get minus 3i. I get plus 3i. Then I get minus 9i squared. But remember, minus 9i squared is minus 9 times negative 1, which all nets out to be plus 9. This cancels. 1 plus 9 is 10. The product is 10. The sum is 2. So, the polynomial that will contain these two guys as roots is x squared minus the sum times x plus the product. This guy. This is a second degree equation that has those two guys as roots. However, this does not have negative 2 as a root. So, and there's not a pair that I can do the sum and the product thing with. So I say, what factor goes with negative 2 as a root? And that would be x plus 2, right? That's what would give me negative 2, because negative 2 plus 2 would be 0. So equals 0. All I have to do now is multiply that out, and that will be my answer. So here we go. X squared times x to the third. X times this, minus 2x squared, x times 10, 10x. Now 2 times everything, 2 times x squared is 2x squared. 2 times negative 2x is minus 4x, and 2 times 10 is 20, okay? Add this garbage together, and guess what we get? Let's see, x to the third, oh my gosh! That cancels, so I don't even have a squared term. Plus 6x plus 20 equals 0, and there's your answer. It doesn't really matter if you leave that little gap there or not. You could just write them all next to each other, but there's the answer. X to the third plus 6x plus 20 equals 0. Good enough. All right, we're just moving right along. Now we've got, they wanted us to do long division. This guy divided by this guy. One thing I will point out on this problem is there is a missing x term. Look, x squared plus or minus whatever you want to put, 0x minus 2. So there is a missing x term, which means there's going to be some, we've done some problems like that before where there's gapping. I'll show you as we go through it. We're just, all we want to do is what does this answer turn out to be using long division? So here we go. Okay, what does it take to turn x squared into 3x to the third? It's going to take 3x. So I put it above the x, 3x. 3x times x squared is going to be 3x to the third, just like I planned. 3x times negative 2 is minus 6x, and that's what I'm talking about. Since there's no x term here, this guy's going to be skipped, and I put my minus 6x so that it lines up with this x, right? My squared term is going to be left blank. Then I want to subtract. But remember, subtracting is another way of, adding the opposite is another way of subtracting, so that's what I'm going to do. This is 0. Negative x squared and nothing is still negative x squared. Negative 4x plus 6x is plus 2x. And then bring down the plus 1. Wait a minute, okay. Now, what happens? Let's see. What does it take to turn x squared into negative x squared? Negative 1, right? This times this is negative x squared. This times this is plus 2, right? Leave this as blank because the 2 has to go under the constant there. Now I'm going to subtract that, which is the same thing as add to opposite. So plus, plus, minus. Oh my gosh, nothing. 2x and nothing is 2x. 1 and negative 2 is minus. Wait a minute. I thought my remainder was supposed to be 0. Where did I mess up? The answer is I didn't mess up. The answer does not have to be 0 because they did not tell me that this goes evenly into this. They said find what this divided by this is with long division, right? So this one doesn't go evenly. In fact, there is a remainder. How do we deal with that? We go this guy right here, 3x minus 1. That's the division part. And then what's the leftover? Plus this guy over this guy. That's how you write the remainder. This guy over x squared minus 2. That is the answer to this guy divided by that guy. All right? Okay, now, number 11. hopefully you understood what this one was asking. This, I would have to say, this is probably the easiest problem on the entire assignment. You say, but it's number 11, it's the last problem. Aren't those always the hardest? Well, clearly not. They're not always the hardest because it's probably the easiest. Now, maybe you didn't understand what it was saying, but here's what it says. Use the rational root theorem to determine which of the following could not be a root of this guy. Which of these cannot be a root of this guy, these guys? Oh, I didn't read what the possibilities were. I was going to write that down. Okay, here I have it on this page. They are -4, 2/3. Here's my choices. -4, 2/3, 3/4, or -1/2. Which of those is not a possible root? It's not asking which one of these is not a root. It's saying which one's not a possible root. So don't worry about these guys yet. Let's figure out what the possible roots of this guy look like first. Here it is. They're going to be factors of the constant on top. So factors of 8 on top, ±1, ±2, ±4, ±8. Those are factors of 8 on top. Over factors of the leading coefficient, which is 6 on the bottom, ±1, ±2, ±3, ±6. Those are factors of 6 on the bottom, factors of 8 on the top. Now I'm going to make every possible fraction I can make with those bottoms and those tops. Okay, here we go. I'm going to do everything over 1 to begin with. So we have ±1, ±2 over 1, ±3 over 1, ±4 over 1. Oh, not 3. Whoa, what is wrong with me? 3? 3 is not one of them. It's these guys over 1. So ±4, ±8, right? All of those guys over 1. Now I'm going to do all these guys over 2, ±1/2, ±2/2. But wait a minute, that's just 1. It's already accounted for, right? ±4/2. Well, that's just 2. It's already accounted for. ±8/2. Well, that's ±4. So those have all been accounted for already. Okay. How about 3? ±1/3, right? ±2/3, ±4/3, ±8/3. Holy moly, I'm running out of room. Comma. We'll go over here. That 8/3. Now, how about 6? ±1/6, ±2/6, that's just 1/3, ±4/6, that's 2/3, ±8/6, that's 4/3. So all of those are accounted for. So here's all the possible rational solutions. Now, what does the question say? The question didn't say what are all the possible rational solutions. They said, which of these is not a possible solution? Okay, well, look, -4 is on my list, so it's not it. 2/3 is on my list. 3/4, wait a minute. 3/4 isn't on here. And then look, -1/2, yep, -1/2 is on there, right? The one that's not a possible rational solution there would be 3/4. All right, so that is how that works. And now, for the grand finale, I am going to show you a problem that I'm going to solve by the rational root theorem. Here we go. Let me just show you. I just have to erase this part right here. I just need a little room. Okay, here we go. Rational root theorem. Here's my equation. Okay, x to the third minus 6x squared, x to the third minus 6x squared plus 13x minus 10 equals 0. Okay, so I want to solve that equation by using the rational root theorem. Notice they're not giving me any roots, they're not doing anything, and it's a third degree equation. What am I going to do? I'm going to use the rational root theorem. So the first thing I'm going to do is figure out what are the possible rational solutions of this guy. Well, they're gonna be factors of 10 on top. So here we go, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10 on top, over factors of, oh my gosh, luck is with me, plus or minus 1. I don't even have to look at any fractions. All of my possible rational solutions are all integer numbers. Look, they're gonna be, here we go, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Oh my God, can you believe it? I went from infinity possibilities down to 2, 4, 6, 8 possibilities. From infinity down to 8. Can you believe it? Infinity to 8. I can't believe it. Oh my gosh. Even if I have to try all 8, that's not that bad. So let's start trying them. What does it mean to try them? I'll show you. Now you can start wherever you want. You can start with 10 if you want to. I'm gonna just go in order. I'm gonna start with 1. So here we go. Let's see if 1 works. What do? I'm gonna do synthetic division with these guys and see if I get 0 remainder. So I get 1x to the third minus 6x squared, 13x minus 10. And big question, is that a 0? If that's a 0, it works. If it's not a 0, it doesn't work. Doesn't mean you got it wrong if it's not a 0. It just means it's not a root. Okay. So bring down the 1 under here. Multiply. 1 times 1 is 1. This and this is negative 5. Multiply. Negative 5. 13 and negative 5 is 8. 8 times 1 is 8. Negative 10 and 8 is negative 2. Is that 0? No. So you know what that means? Not a root. 1's not a root. Okay. So knocked one of them down. Let's try negative 1. Okay. Let's see if that works. We got 1, we're using the same numbers, 13, negative 10. Uh-oh, this thing is not that great. Oh, so close. It bounced off there. It almost made it, but it bounced off. Okay, bring it down. 1, negative 7, regular 7, 13 and 7 is 20, 20 and negative 1 is negative 20. Negative 30, that is not 0. Uh-oh. Just hang in there. Okay, let's try, for instance, 2 now. 2. Okay, we use the same ones. 1, negative 6, 13, negative 10. Then you bring this down. 1, this time this is this, negative 4, negative 8. 5. Oh, yes! You know it! All right, so see, it makes it that much better when you go through this garbage and you finally get it. It makes it better. Yeah. So I got one of my roots is 2 is going to be a root. Now, does that mean none of these others work? No, possibly. There could be more than one rational root, but I've knocked it down to that. Now, notice what I did. I knocked it from a 3rd degree down to a remainder, constant, first power, second power, 2nd degree equation. I could solve any 2nd degree equation by either factoring, quadratic formula, or I could even do completing the square, quadratic formula at the worst case scenario. So let's try this. So I'm going to look at this polynomial. Once you get it down to a 2nd degree, you don't have to keep trying this, right? Now you got it down to a 2nd degree. You can say, okay, x squared minus 4x plus 5 equals 0. That's the other 2 roots are inside of there. So can I think of 2 things that multiply to be 5 and add to be 4? Wait a minute. No. I could think of 2 things that multiply to 5 and subtract to be 4. That would be 5 and 1, right? But I can't think of 2 things that multiply to be 5 and add to be 4. So this thing does not factor. So I'm going to have to go A is 1, B is negative 4, C is 5, and put them into the quadratic formula. Very important to know the quadratic formula. I hope you know it. You should know it. If you don't know it, learn it. X is opposite of B, so regular 4, plus or minus square root of B squared, so negative 4 squared, minus 4AC, 4 times 1 times 5, all over 2A, 2 times 1. All I did is plug numbers in for letters right there. Now I'm going to simplify. X is 4 plus or minus square root of 16 minus 20 over 2. Wait a minute. That gives me 4 plus or minus square root -4 over 2. And wait a minute, square root -4 is 2i, right? This is just 2i. So look what it's going to give me. X is 4 plus or minus 2i, the whole thing over 2. Now, everything has a 2. Just like this, if this was 4 plus or minus 2x over 2 or whatever, everything has a 2. So what do? Factor out the 2. Okay, 2 times 2 plus or minus I over 2. These guys cancel, and you get 2 plus or minus I is the other 2 roots. So the entire solution set to this thing would turn out to be 2, the rational root we figured out, and 2 plus or minus I. And there's my entire solution. It also shows me that, hey, it was a pretty good idea to quit after this and not keep trying these guys, because none of these other guys would have ended up working. So it's better to just, as soon as you get it down to a 2nd degree, go ahead and solve that 2nd degree. Anyway, that is how it works. That's the rational root theorem, how it works. And there you go. So I'm going to give you today's homework. Homework number 50. Wait, that was number 50. I got to give you a lesson for number 51. So actually, this was just the review of homework number 50. So hope you enjoyed it.